Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
In the intellectual firmament of the late 18th century, an epoch defined by its unshakable faith in reason and the universal applicability of natural law, few stars burned brighter than that of Pierre Simon Laplace, hailed by his contemporaries as the French Newton. Laplace embodied the Enlightenment's grand ambition to subject the entirety of the physical world to the precise and elegant language of mathematics, while his multi-volume masterwork, the Traité de mécanique céleste, stands as the technical monument to this ambition. It is his 1796 publication, Exposition du système du Monde, that represents its most articulate and accessible public expression. This work, a sublime piece of scientific literature, presents a vision of the cosmos that is both majestic and mechanistic, a self-sufficient system governed by immutable principles. The Exposition achieved its profound influence through two central pillars: the Nebular hypothesis, which offered a naturalistic genesis for our solar system, and an underlying philosophy of causal determinism that would define the scientific worldview for the subsequent century. It is a work that completed the Newtonian revolution, presenting the heavens as a perfectly predictable clockwork, a universe whose intricate workings were entirely comprehensible to the human mind. The intellectual terrain upon which Laplace built his edifice was charted definitively by Isaac Newton a century earlier. Newton's Philosophiae Naturalis Principia Mathematica had established the law of universal gravitation, a force proportional to the product of two masses and inversely proportional to the square of the distance between their centres. This single law explained the fall of an apple and the orbit of the moon, unifying terrestrial and celestial physics in a single, powerful framework. Yet, the Newtonian system harboured a persistent and troubling question: the long-term stability of the solar system. The gravitational pull of each planet on every other introduces minute perturbations into their orbits. Over millennia, would these tiny deviations accumulate, eventually disrupting the delicate harmony of the system and casting planets into the sun or out into the cold of deep space? Newton himself suspected they might, suggesting that the occasional divine intervention was required to reset the cosmic clock and maintain its order. This was the great, unsolved problem of celestial mechanics, a challenge that occupied the finest mathematical minds of the 18th century, including Leonhard Euler and Joseph Louis Lagrange. Their development of sophisticated analytical techniques, particularly perturbation theory, provided the powerful mathematical engine that would enable Laplace to demonstrate the system's inherent stability, thereby rendering divine maintenance an unnecessary hypothesis. The Exposition du système du Monde was conceived as a grand synthesis of these decades of technical labour, translated from the arcane language of differential equations into the eloquent prose of the French academician. Its purpose was to unveil the architecture of the cosmos for an educated public, a readership steeped in the classics and philosophy, but unversed in the intricacies of calculus. The book is structured in 5 parts, moving with masterful logic from the apparent motions of the planets as seen from Earth, to their true motions in space, to the physical laws of gravity that govern those motions. It culminates in a concise history of astronomy, placing his own era at the pinnacle of a long quest for knowledge, and concludes with a profound reflection on the origin and future of the universe. The genius of the Exposition lies in this structure, which guides the reader from simple observation to the deepest theoretical conclusions without a single equation, a feat of popularization that has few equals. Laplace's prose is a model of clarity and precision, conveying complex ideas with an elegance that made the work a literary as well as a scientific triumph. He created a compelling narrative of discovery, one that celebrated the power of human reason to demystify the heavens. The most celebrated and original contribution within the Exposition is its final chapter, where Laplace outlines his nebular hypothesis, a comprehensive theory for the formation of the solar system. He posited that the sun and planets originated from a vast, slowly rotating, and intensely hot cloud of gas, a primordial nebula. As this nebula cooled, it would contract under its own gravity. The principle of the conservation of angular momentum dictated that as its radius decreased, its speed of rotation would increase. This accelerating spin would generate a powerful centrifugal force at the nebula's equator. At a certain point, this outward force would balance the inward pull of gravity, causing successive rings of gaseous material to be shed from the spinning mass. Each of these detached rings, he argued, would then continue to orbit the central protostar, eventually condensing and accreting under its own gravity to form a planet. The planets, in turn, would replicate this process on a smaller scale, shedding rings that would become their moons. This was a breathtakingly audacious and entirely mechanistic account of cosmic genesis, while Immanuel Kant had proposed a similar idea in 755. Laplace's formulation was more physically grounded and dynamically compelling. He provided a causal chain of events driven by established principles of physics, gravity, cooling, and rotation. The nebular hypothesis offered, for the first time, a scientifically plausible narrative that explained the solar system's most conspicuous features: the coplanar and nearly circular orbits of the planets, their revolution in the same direction as the Sun's rotation, and the similar orientation of their satellites. Its impact was immediate and transformative. It replaced teleological explanations and appeals to a divine architect with a natural, evolutionary process. This vision of a self-creating cosmos became the dominant paradigm in cosmogony for over 100 years, shaping scientific thought and capturing the public imagination with its powerful, emergent story. Its elegance, however, concealed a significant flaw. A rigorous analysis of the conservation of angular momentum reveals a paradox. While the Sun contains over 99% of the solar system's mass, the planets, particularly Jupiter, possess the vast majority of its angular momentum. In Laplace's model, the central body should have retained the bulk of the rotational motion. This discrepancy would become a persistent thorn in the side of the hypothesis, a puzzle that would be resolved only with later theories of magnetic braking and solar wind in the 20th century. Beyond its specific account of origins, the Exposition promulgated a deeper, more pervasive philosophical worldview by demonstrating that the observed perturbations in planetary orbits were periodic, self-correcting cycles. Laplace effectively proved the long-term stability of the solar system. The intricate celestial clockwork needed no external hand to wind it or to correct its course. It was a perfect, autonomous machine. This conclusion is immortalized in a famous, if possibly embellished, anecdote. When presenting his work to Napoleon Bonaparte, the first consul allegedly queried Laplace on the role of God within his cosmic system. Laplace's reported reply was devastating in its simplicity: "Sire, I had no need of that hypothesis." This statement, whether uttered precisely as recorded, perfectly encapsulates the spirit of the work. The universe it described was causally closed, its operations entirely explicable through the interplay of matter and physical law. This worldview is the essence of what became known as Laplacian determinism. The full expression of this idea, the famous thought experiment involving a vast intelligence or demon capable of knowing the position and momentum of every particle in the universe, appeared in a later work, his 1814 Essai philosophique sur les probabilités. Yet, the intellectual foundation for this demon is laid throughout the Exposition. If the universe is a mechanical system obeying fixed laws, then a complete knowledge of its state at any given moment is sufficient to predict its entire future and to retrodict its entire past. For such an intelligence, Laplace wrote, nothing would be uncertain, and the future, like the past, would be present to its eyes. This powerful and austere vision became a foundational assumption of classical physics and a cornerstone of 19th century scientific positivism. Its implications resonated far beyond the confines of astronomy, challenging traditional notions of free will, divine providence, and the very nature of time and causality. It presented a universe stripped of caprice and mystery, a grand, intricate, ultimately predictable In conclusion, Pierre Simon Laplace's Exposition du Système du Monde stands as a landmark of scientific thought and a masterpiece of its communication. It was a dual achievement, functioning as both a brilliant piece of popular science that made the heavens accessible to the Enlightenment mind and a profound philosophical treatise that championed a deterministic and self-sufficient cosmos. Through the nebular hypothesis, it provided a powerful and enduring framework for understanding our cosmic origins, a framework that would guide astronomical inquiry for generations despite its eventual need for revision. Through its successful demonstration of the solar system's stability, it offered a universe governed by unbreakable and knowable laws, a vision that became central to the identity of physical science. While the 20th century revolutions of quantum mechanics, with its intrinsic uncertainty, and chaos theory, with its sensitivity to initial conditions, have revealed the profound limits of this perfect clockwork vision, the grandeur of Laplace's achievement remains undiminished. His Exposition is the ultimate testament to the Enlightenment's confidence, an elegant and powerful declaration that the human intellect could, through reason and mathematics, grasp the entirety of the world system.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.